Welcome to the Virtually Speaking podcast. My name is Pete Fletcher, and joining me as usual is my good friend, Mr. John Nicholson. John, how you doing, man?
Good. Feeling a little better than normal. I did some oil paint down in the kitchen today, and I don't think I fully ventilated this office. So let's see if I can remain coherent for the whole podcast.
I love that. Yeah. I can't wait to see your work.
It's going to be beautiful.
Yeah. Looking forward to it. Lots of beautiful things this week. Obviously, it's been announcement week. We've had VCF 5.2 came out. We spoke last episode about vSphere Foundation. Gave some folks an understanding of that. But I think this one is probably one we've been doing for a while. It's part of our heart here at Virtually Speaking, and that's talking about vSphere in general. So. Joining us to give us all the updates on the latest version of vSphere is our good friend, Mr. Féidhlim O'Leary. Féidhlim, welcome back.
Thank you, Pete. Thank you, John, for having me. Always fun to be back chatting with you folks.
Yes, I love that Canadian accent you have there, right? You do live in Canada, right?
I do now, so I'm trying to, acclimatize to the local lingo.
Yeah. I know that's not what the podcast is about, but you're from Ireland, you live in Canada. Why would you leave Ireland? Ireland's amazing.
It's very wet. It's quite grey. I moved. It's quite sunny here now, but the winters do get cold.
Yeah.
A lot of snow.
Okay. I guess the grass is always greener, as they say, especially in Ireland.
Yeah. Yes.
Yeah. Well, cool, man. vSphere 8 Update 3 just came out, and oh my goodness, you did a great job on the technical overview deck that I saw, there's a bit of a deep dive on all the new features, and I know we don't have that much time to go into everything that came out in vSphere 8 Update 3, but I'd love to spend the next 30 minutes or so just walking through some of the larger announcements inside of vSphere 8 Update 3. Why don't we start with the IS control plane?
Sure. And I suppose the first thing I'm always going to mention when I'm speaking about this is what we used to call vSphere Retenzu. So just, off the bat, this isn't any hugely net new thing. We've had vSphere Retenzu or Kubernetes integration or VM service or infrastructure as a service, all that. We've just wrapped it up in a nice new, more appropriate name going forward. But there's a whole bunch of really cool things that we've introduced now with the 8 Update 3 release, and things that a lot of customers have been asking for. So I'm hopefully they'll be very happy with the progress we've made. And one of the first things that we're doing is we're decoupling the TKG service, the Tanzu Kubernetes Grid service, from vCenter. So in the past, to get additional new TKG releases supported, have your supervisor cluster updated, you have to first patch vCenter. And that sometimes isn't so easy for customers to do. They have to take maintenance windows, they have to schedule it. There may be interoperability problems with other products and services in their environment. So it was an adoption blocker for customers to update their TKG instances and get access to the latest and greatest. So we've decoupled that now. We've removed it from being dependent on vCenter and changed it to be a core supervisor service. And this allows us it to be updated independently of vCenter. We've started moving to this supervisor service model a couple of releases ago. Things like the VM service is a core supervisor service, Valero for backup and restore, and there's a whole other bunch of supervisor services that you can install and manage. And now we've made TKG one of those. So it gives a lot of more flexibility for customers to be able to adopt the rapid cadence that Kubernetes releases do come out on. They come out much, much faster than vSphere releases. So it allows them to be adopted more quickly without having to have that patch of vCenter, that update of vCenter be a potential adoption blocker. So should really, be great for customers.
That's to have to be dependent upon vSphere is almost counterintuitive to the community, that is, the Kubernetes world of, constantly upgrading and, just upgrading to the next version. How many versions of TKG, or how many versions in general do you think the Kubernetes goes through in like one cycle of vSphere? It's got to be.
Oh God! I mean, they release new versions. I think is it every 3 months. Something like that, we release new patches for vCenter, maybe along the same cadence, but not new major vCenter versions, not as quickly at all. And I suppose it does goes without saying as well, we still want customers to patch and maintain their vCenter versions on the latest and greatest as much as possible. But we do
But
acknowledge
aligning
that
those
that's
change control windows between the
yeah,
developer and the infrastructure teams, those are two groups that, may have different goals or different hard freezes on when they can upgrade and things.
yeah, exactly. Yeah. So, and the other really feature that a lot of customers have asked for in the TKG space as well is auto scaling. So, being able to automatically scale up and scale down those TKG clusters based on demand.
So the
When
pod VMs get substantiated based on load.
exactly. So again, that can be installed and enabled very simply. It's a standard package using your familiar kubectl or Tanzu CLI. Very easy to activate and take advantage of this for that auto scaling feature as well. One that customers have been asking for quite some time. And staying with again, kind of the TKG space or the Kubernetes cluster space is the vSAN stretch cluster support. Again, this is one that customers have been asking for quite some time. It took a little bit of work on our back end from testing perspective, because it's not a simple configuration to incorporate both essentially a stretched vSAN cluster with what is ends up being a stretched supervisor cluster or stretched Kubernetes cluster as well. So there are some requirements to take into account. Our documentation will outline all those sort of limitations and requirements, and just make sure that you're following those best practices to get the best configuration possible. Kind of in a nutshell, we recommend not trying to stretch the control plane VMs of the Kubernetes clusters, spanning multiple sites or spanning 2 sites, like this diagram on screen shows. But you can put the worker nodes on site A, worker nodes on site B. That's no problem at all. So just take that into account. Check the documentation for the best practices, and you can use affinity rules as well to make sure that nodes are placed on the correct site as well.
Oh, okay. And so this is very specific, obviously, to Kubernetes. Obviously, vSAN has offered support for stretch cluster for a while, so this is just new to the okay.
Yeah, this is melding both worlds. We haven't supported putting the vSphere IaaS control plane and the Kubernetes clusters on a vSAN stretch cluster up until this point. So now we're closing that gap.
Well, and this is an interesting one, because I remember originally people asked for this, and I would talk to my DevOps hipster friends, Miles or whoever, and they'd be like, "Well, why would you ever put Kubernetes? You should have multiple pods, and you should at a higher level do this type of orchestration." But the amount of customers that have been like, "Look, we don't want to manage that. We don't want to manage AZ design.
Yeah,
we want to do that. Like, let's just have an easy button." And this, well, I'm sure this has affinity rules and things you have to consider and make sure you're, the autoscaler being enabled is nice, because if you have a site fail, then you may want twice as many of these things. But that does sound like this is kind of meeting customers in the middle in the reality of what they want to deploy. And there's been this historical kind of design paradigm, I feel like, in the DevOps space of like, let's assume the infrastructure is garbage and let's try to design around that and do it all at the higher level. And the reality is that there's different data center constructs or areas of like, hey, this data center, it's not durable, or I've got 2 sites. This is a much more familiar paradigm for protecting and providing high availability and being able to kind of meet in the middle. This is cool. I think a lot of people will actually use this.
And one other new thing that we're introducing is it's an opt-in user interface. We're calling it the local consumption interface. And this is actually something that we've taken out from Area Automation, which provides you what we used to call a cloud consumption interface. We're taking a lot of that UI out and giving it to you directly within vCenter. We're calling it the local consumption interface. Now, this actually it's not there out of the box. It is enabled by one of those supervisor services that I mentioned earlier. So it is something that you again will be dynamically updated. It's not going to be tied to a vCenter release to get new abilities and new features, because it's a supervisor service. But it opens up a much more verbose user interface to manage things like complex specifications for VMs and TKG clusters. You can customize some YAML manifests as well, creation of secrets and config maps. A lot of those nitty gritty things that more the DevOps focus personas will look at. So it just gives you a whole suite of additional options outside of the basic vSphere interface. But it's all embedded within the vSphere client. It's not a separate appliance or anything like that. You just have to deploy it as
vCenter. This is generated from the vCenter server appliance. It goes and spins out the containers or the CRX.
Yeah, it spins out two little pods, I believe, because I just deployed in my lab actually before this recording.
Will this work on a single node? I'm like, how many home? Because VRA always felt like a lot for a home labber, but this looks like something that actually I might be a little more approachable.
Well, to get this, you need a supervisor cluster already stood up, which does require a minimum of 3 hosts. There are some
if I get to 3 hosts,
unsupported ways to do it in one, but supported, you do need 3.
Yeah, RAF
needs
3, so etcd.
But it's a very lightweight deployment, very quick. Again, it'll be able to be dynamically updated or outside of the regular vSphere cadence as a supervisor cluster, and just gives more of a verbose user interface for those that are looking for it.
So is this something that somebody would use if they were using VMware Cloud Foundation and vSphere Foundation, or is this for anybody that's using vSphere regardless of the setup that they have?
Yeah, it could be used for both. You could be using full VCF stack. You could be using the VVF stack. If you've
the
got
network overlay obviously may require stack, so you may need full VCF.
Yeah, I mean, you can use this with NSX-based networking stack. The vSphere networking stack supports the vSphere services or the supervisor services as well. But I believe going forward, we're only licensing the vSphere IaaS for VCF. I think I'm not 100% sure on that licensing aspect.
Okay. This is not a PNP discussion or a pricing or licensing, so we will not hold you to that.
Yeah. So that's kind of the highlights from the vSphere IaaS space. Like I said, it's the new thing that we've referred to that we used to call vSphere Tanzu. We're moving away from that Tanzu branding or that Tanzu name here. So it's vSphere infrastructure as a service. So there'll be more coming to that space as well in the future. And I guess the next major thing that's always kind of close to my home, because it's usually what I end up getting roped into a lot, is the whole area of lifecycle management. So vSphere lifecycle management, it's a bit of a beast. There's a lot that's involved in it. We've kind of got 3 main areas when we talk about lifecycle of vSphere. We've got the vCenter lifecycle, we've got the ESXi lifecycle or the cluster lifecycle, and then configuration management. Now, there's not a major update with the configuration side of things with vSphere configuration profiles. We are now supporting baseline-based clusters. So if you're not one of those customers that has moved off baselines, which are deprecated, you can still adopt vSphere configuration profiles now. But you should be moving to VLCM images.
What was that, VUM, right? Was it vSphere update
manager? Yeah, exactly, VUM. Now, vCenter reduced downtime update was a big hit with customers in the last update, and update 2 allows you to do an update of vCenter with only incurring less than 5 minutes of downtime. 2 to 3 minutes on average, and we're always going to try and get it down. I think our goal is to get it under 60 seconds. But we're not there yet. But we have introduced additional topology support, things like being able to do the RDU update with enhanced link mode, non-self-managed vCenters, vCenter HA, things like that. So the whole slew of different topologies that vCenter can be in. And we're doing an automatic switchover now. You can still opt to do the manual switchover, which might be handy if you do want to have that control. But if you want to just do the end-to-end, click the button, walk away for an hour and get your coffee, the automatic switchover will automatically take place as well. But the biggest thing that we've introduced in vSphere 8 Update 3 is our first release of vSphere Live patch. Now, this is going to be a game changer. And, a 1.0 release feature. It's really good out the gate. It's only going to get better. And the goal of this is that being able to patch your ESXi hosts without having to evacuate them, without having to go into maintenance mode, migrate all the VMs, do the patch, reboot, migrate them all back, and then repeat that, a dozen times or however many hosts you have. So this allows us to keep the VMs in place, keep the VMs running, do the patch, and there's no interruption. There's no downtime.
So there's no reboot? There's never a reboot?
There's no reboot to the host.
Huh.
Now this is going to target it's only targeting a subset of ESXi. Let's say we won't be able to live patch every single patch or every single ESXi update out the gate. We're currently able to do it for the part of ESXi that handles the virtual machine execution runtime. Right. And this is where we do have a lot of cases where historically this has been where some vulnerabilities have been in. So that's why we targeted it.
Focused areas, that area.
Exactly. That's where we started. Let's try and get live patch into the area that we expect there to be the higher number of security vulnerabilities, in the future, so that we can patch those quickly, have customers adopt these patches quickly without incurring downtime. Now, the way this works is, and I saw a demo of this or something very similar in one of our radio events, I'd say could have been 3 years ago or something like that. And it looks like it's something very similar to what we've actually released here. And the way it works is, if we think about ESXi, it's a bunch of files, it's a bunch of processes. We essentially clone a copy of some of the files and some of the processes that we're going to patch. So we have two instances of a couple of files, couple of processes running in parallel. We patch one instance, and then we do what's called a fast suspend resume on the virtual machine so that they pick up the new patched processes.
So it's like you hit pause, then resume really fast, and you swap the golden statue in the meanwhile.
Exactly. If we want to get really in the weeds and the technicalities, it's very similar to an extremely, extremely fast localized vMotion. It's kind of very similar technology, but it's nothing new, actually. This fast suspend resume has been around for a couple of releases now. Anytime you hot add any disk, NIC, GPU, memory, CPU, do a lot of those.
That's how we got around that.
Yeah, it's that technology is used. So chances are your VMs today have already been doing fast suspend resumes all along, and it's non-disruptive. The only couple of VM types that don't support this yet are things like fault tolerance, VMs that are using one-to-one physical direct path I/O devices, and those vSphere pods, because we don't treat those as regular virtual machines. But for 99% of your VMs, doing a fast suspend resume is a non-disruptive task. So this is hopefully going to be really, really useful. Like I said, it is a first initial release of this technology. So not every patch that we release going forward after U3, U3A, B, C, whatever we decide to call them, not all those patches are going to be live patchable. So it'll be all noted in the release notes. It'll be noted in VLCM. It'll tell you, hey, this is live patchable. Do you want a live patch or do you not? And it's all opt-in right now. We don't default to live patch. That's kind of how we do. We did that with Quick Boot as well initially. It was an opt-in, and then we made Quick Boot the default. I could see the same happening here. We'll eventually make live patch the default.
Yeah, a couple of years from now, no one will ever have even the new admins will come on and be like, wait, what? There was a time when this wasn't just the way it is?
Yeah. Reboot? What's that?
Yeah, exactly.
So yeah, that's a huge thing now in vSphere 8 Update 3. VCF 5.2 also supports that. I know sometimes there's a little bit of discrepancy between what standalone vSphere supports and VCF, but it's great that VCF will support live patch as well, or does support live patch right out the gate as well.
Yeah, for sure.
It'll all be called through SDDC Manager as well. It'll call the APIs. It's all pretty seamless. I touched on
this feature. I know we need to move on, but this feature I think is going to have the biggest impact on operators out there, because the amount of people who still do eyes on glass for upgrade cycles for various reasons, they don't just yell YOLO in the data center and wander off. oftentimes those change windows are after hours. Like they've got other places they'd rather be. They've got kids they'd rather read a bedtime story to.
Yeah.
Or they've got security issues that they can't find a window and they drag out and they put risk, and people are sleepless over that. This is something that as far as impact of potential customers and potential man hours saved, this is I know we don't need to dwell on it the whole podcast, but this is a huge deal.
No, it is, and that's a fair point. Even if you're doing a traditional patch today and you're evacuating a host, your VM's vMotion is rock solid. You're still not incurring any downtime, but it can just take a long time if you've got hundreds of VMs, dozens
People are
and dozens
sizing
of hosts.
People size their clusters based on evacuation times. It's very common to people say, look, it's non-disruptive, but we don't want to have we don't want to go above 12 or 14 nodes because our patch windows are only 1 hour or 2 hours or something. And the Gantt chart works backwards from that timeline to entire design decisions that will impact in data centers. So
makes sense.
Yeah. And so the only other thing I'll mention before we jump on to the next section, because they're related, is we're going to talk about dual DPU support. And vSphere Lifecycle Manager, it just automatically supports dual DPUs. There's no change to your workflow. It's the same as if one DPU, two DPUs, no change. It's just automatic out of the box support. And dual DPUs has been something customers have asked us for since we released our first DPU configuration. The first question they asked was, okay, can I do two? And it's great that you can now, and you can do it in two different ways. You can use dual DPUs in one of two ways. You can do it in the high availability configuration, which was probably one of the main reason that customers asked for the dual DPU configuration. They didn't want to have that single point of failure in their offloads. So you can put your two DPUs into an active standby mode. They're both connected to the same vSphere distributed switch. So you have a failover. If one of the DPU fails or the uplinks on the DPU fails, the DPU might PSOD because it's essentially running an instance of ESXi itself. We'll do a failover to the next DPU or the standby DPU. So it provides that high availability that customers have been asking for, and has been an adoption blocker for some customers to use DPUs in their vSphere environments. The network offload, we do network offloads via NSX to the DPU. So we're freeing up some of those CPU cycles, putting that traffic down onto the DPUs itself. When it comes to lifecycle, it's almost like having a child version of ESXi installed in your host, because there's an instance of ESXi on the DPU itself. Like in the screenshot we have here, we're looking at a host and it's got two DPUs. Each of those DPUs has an instance of ESXi, but you just have one remediation event. You remediate your parent host and it pushes the ESXi instance of the patch down to the DPUs. I guess it's a good reminder that live patch doesn't support DPUs at this time as well. So we'll get there, but if you want to try and live patch a system that has DPUs, unfortunately you'll have to fall back to the traditional method, because we do need that full reboot cycle when patching the DPUs.
Okay. So in the context of this, though, like on the screenshot, essentially what we're doing is we're upgrading the ESXi version that's on the DPU, but we can do that non-disruptively because we've got the availability having the other card.
Unfortunately, no. When we're doing the lifecycle aspect of a host with DPUs, that's still an offline task. You still have to put the host into full maintenance mode. The VMs will need to be evacuated. So yeah, sorry. Now I understand. I understand your question now.
Okay.
Yeah, it is let's call it a traditional maintenance window. Host is evacuated. It's in full maintenance mode. Nothing's running on it.
Okay,
and
good.
Then we do the patching.
All right.
And so, but it's a great question. Great question. In the second way you can use two DPUs is just to add network offload capacity. So we just talked about them using them in an active standby method. That's where both DPUs are connected to the same distributed switch. Mm-hmm. Or we can have two DPUs that are essentially operating independently of each other. They're both connected to different vSphere distributed switches. So you have multiple VMs, different workloads connected to different switches, doing offloads to different DPUs.
Okay.
There's no interaction between the two DPUs. They're essentially isolated from each other. It's the same configuration if you had a single DPU setup, you just now have two. Again, from a life cycle perspective, again, it's a full maintenance mode, evacuation, remediate.
I was just going to say the lack of redundancy may sound kind of counterintuitive, but if you spend some time around the telco people, they'll often have these applications that they'll have load balancers or some type of real high throughput SIP proxy, RTP proxy, or something going on that they'll say, look, I handle my own redundancy at an app level. I'm just looking for how do I max every single port simultaneously, and they'll have 4 hosts that all have multi-100 gig or whatever insane thing they're doing. And so the lack of redundancy may sound weird, but when you, in the context of like telco edge networking stuff, it makes more sense.
Yeah, that's a great point. And so that's our DPU story, which has evolved since vSphere 8 first released. Let's switch gears now to GPU story, because that's been a huge focus, especially with the buzzword of 2024 being AI.
Absolutely.
And we're continuing that work. And I would preface that a lot of what we're doing with GPUs support isn't just for AI. It does support any workload that can leverage a GPU. The machine learning workloads, graphics applications, some compute applications that can leverage those CUDA layer for things like that. So high performance computing. So it's not just for AI, even though that's where a lot of the focus tends to be. And we've been working with NVIDIA for a long time now on the vGPU technology. And when it first released, I think in the vSphere, I think it was even back in 6.7 days, there were some limitations around the size of the vGPU profiles. They have different vGPU profiles depending on the workload. I think NVIDIA uses terminologies like profile A, B, C, Q, depending on what they're targeted for. And initially, we had to have the same profile on the same host using the same GPU. It was quite restrictive. The memory sizing had to be the same. We've removed all those limitations now. We've worked with NVIDIA. We've gotten all that ironed out. So now you can mix and match to your heart's content, have different profiles running on the same host, leveraging the same physical GPU, different memory sizes. Some VMs might use 4 gigs of GPU memory, some with 8, some with 16, depending on the underlying hardware itself. And the other thing that we're exposing to the vGPU profiles for the first time is the GPU's media engine. And there's typically one media engine per physical GPU. Some have 2. I think some of the really new high-end ones have 2, but it's common to just have 1. And this is the part of a GPU usually handles things like video rendering, accelerates that H.264, H.265 video codecs, things like that. So for the first time, we're able to expose one of those media engines to a vGPU profile to, again, add value to those sort of workloads that want to take advantage of a GPU media engine. So that's really good. And we've really, we've made GPU-enabled VMs truly first-class citizens in vSphere. They can vMotion, you can back them up. They can interoperate with snapshots and DRS and HA and stuff like that. It's really, really great.
So that media engine, that's primarily within the Intel context, or is that an NVIDIA context?
No, it's in an NVIDIA context. Yeah. Okay. They typically have one, they call it the media engine or the NVENC. It's like NVIDIA Video Encoder, I think is what that stands for. Other GPUs have similar hardware acceleration.
Yeah,
and
I've
some
seen
CPUs,
them before on the desktop side, but that's for like offloading my VoIP, or like, for instance, this video call that we're having right now, that type of codec offload. Is that more for VDI, or is that for, like, I've seen like YouTube has these giant batches of systems that just sit there and churn large amounts. So I assume other broadcasters. Is it for bulk media processing, or is it more for just VDI handling?
I believe it's more for video processing. You could have farms that are exporting video, rendering video from, massive
AI against surveillance,
4K. Yeah. YouTube, when you upload a video to YouTube and it first gives you that 320p resolution, and you wait 10 minutes and
I
you
was
finally
so
have
angry at that
your
recently. We copied some videos between channels, and I was like, "Who uploaded my potato
yeah,
quality of my beautiful
yeah.
video?" But
Yeah.
So
then,
it's
they
stuff
get
like that.
around to it later.
Yeah.
Well, I like the idea of using profiles where you can actually assign the GPU resources to different consumers without having to, and mix matching, because there's going to be different requirements out there. These things are way too expensive to be limited to the use cases that you can assign to them. So I think this makes them more wisely used in organizations. These pretty valuable resources.
Yeah, and we've made it easier as well to just see things like the performance of your GPUs, the compute, the memory that they're consuming in the vSphere client. There's some performance charts. There's a summary tab, sees that total view. We've made it easier to enable mobility for those VMs as well. In past releases, it was all advanced settings, digging around in config files, stuff like that. You can enable the workload or the mobility of vGPU enabled VMs in the DRS settings now as well. So it just makes it much more simpler.
And the actual consumption is made visible inside the performance. So this is not something that needs to be done through extra tools. I can actually just inside of vCenter see what my GPUs are doing and the performance that they're doing and all that stuff.
Exactly. Yeah. Now you'll with vSphere performance charts, you get quite a rudimentary basic view of things, some historical data, ingest this into operations, ARIA operations, and you'll be able to make much more prettier graphs and charts
Yeah.
and stuff. So we've just spoken about things like the vSphere IaaS control plane, lifecycle management, the hardware support that we're doing in GPUs and DPUs. Yeah. There is a whole bunch of other smaller enhancements in the release as well, but I'll just touch on a couple of more quick things and then finish this out. We're expanding our identity federation story. We're adding Ping Federate to our identity providers, joining Okta, Entra ID, or Azure ID, and Microsoft ADFS. There's a whole load of work on vVols that we've done. Now, I'm not the SME on that area. Unfortunately, I'd love to be able to speak to it and do it justice, but you can check out core.vmware.com. We've got a full blog on everything core storage for update 3 as well. A lot of NVMe enhancements as well. But we've done a lot of investment in vVols, and particularly vVol stretch storage cluster support as well. And the last thing I'm going to finish on is hopefully something that'll really benefit customers that we know there has been issues with, and that's the vSphere cluster service. Those 3 little annoying VMs that magically appeared one time in vSphere 7 and have caused you nothing but heartache. We've taken a lot of the feedback on board. We've worked with GS support to identify the root cause of a lot of the issues, and engineering took it upon themselves to re-architect the actual entire vSphere cluster service. It's no longer going to be traditional virtual machines. We're taking some of that technology we first developed in our vSphere IaaS space to make them container runtimes. So they're essentially vSphere pods, but a little bit done differently, but they're using similar technology. So they're running that what we call the CRX runtime. And there's going to be fewer VMs per cluster. Today you have 3, you'll only have 2 per cluster going forward. And because they're a CRX runtime, that's embedded directly into ESXi. So there's no OVA push from vCenter, which has been a lot of the source of the problem.
There'll be no VMDK. There'll be no storage. That
Exactly.
It doesn't have to sit on a data store.
Doesn't have to know about a data store. Doesn't have to push any data from vCenter to the ESX hosts. It all just runs in memory. I think it's about 100 megs per instance. So let's say 200 megs per cluster.
That's a lot of RAM. That's like 20 cents or something of RAM. I don't know. I haven't looked at ECC prices in a minute. It's not reserved though, right? We're good. So
it's interesting that the OVA push was the issue.
A lot of the issues came down to the OVA push, using EAM to manage that relationship. EAM is something that manages a lot of those sort of relationships when we're pushing agent VMs. So it's a incredibly faster at spinning up because it's just a quick CRX instance from one of the ESXi hosts in the cluster. The other thing is that these still will appear to the end user as VMs. You'll still see them in your inventory tree. They'll be still in the VCLS folder. So there will still potentially be a charge cost associated for cloud providers and things like that. Those limitations haven't been removed yet. That those have existed since we first introduced this. So a lot of that does remain the same. They are still required for vSphere HA and DRS to operate optimally.
Can you affinity them to specific hosts or not?
You can still use the affinity anti-affinity rules.
Okay, so if I'm a cloud provider, I can say compute policy. Should stay on the first 3 hosts and reduce the need to license an otherwise empty cluster for DR or something.
Exactly, we really want these to be just non-noticeable. We want these little VMs, these little service VMs to exist, and you never have to worry about them, and they take care of themselves. And hopefully, we've made a good step to achieving that goal.
Yeah, that's awesome. Well, as you mentioned, the majority of the blogs and content that for this release can, as usual, be found on core.vmware.com. That's probably the main spot to go. I know there's a lot of stuff also going on, blogs.vmware.com/cloud, VMware Cloud Foundation. So yeah, the usual spots, but core.vmware.com is a great place to get all the good technical blogs. I've definitely learned a lot on that site, but I know there's a lot more. I don't want to keep you too long, Féidhlim, but I do want to thank you for joining us on this episode. Any closing thoughts about VMware? Well, I will say one closing thought. VMware Explorer is upon us. Quick plug. There's going to be a lot of great sessions to attend. John and I are going to be doing a session on adventures in VMware Home Labs. I'm also doing a session on demystifying DPUs and GPUs. I'll be doing that with Dave Morera. So we'll be talking about all the fun stuff that's new in vSphere 8 Update 3 as well as it pertains to those.
One has a D, one has a G.
Understanding the difference and when you use
Alphabets.
Yeah. Hopefully we'll get a little deeper than that, but it's going to be fun. But Féidhlim, any closing thoughts about this update for you? I know you've been working pretty hard on it.
Yeah, no, this has been a really a larger feature packed update than I was actually expecting when I initially started scoping this out with the engineering team. So it's it seems like our update releases almost become full blown vSphere releases each time. It's great that we're able to pack so much in there and make some meaningful enhancements and changes for our customers.
Very nice, very nice. John, I'll give you the last word on this update.
I would spend some time on this, but I already quick patched my host. So,
It's already done. Very well. Very well. Very expedient of you. Good stuff. Féidhlim, thanks so much for joining us and enjoy the rest of your day.
Thank you, guys.